Greetings, I'm Torin Ragin, a second year business administration scholar from Miami, Florida.
Greetings, I am Layah Gaines, a third year business administration scholar from Upper Marlboro, Maryland.
Greetings, I am Jayda Jones, a fourth year business administration scholar from Clearwater, Florida.
Greetings, I am Taniesha, a third year business administration scholar from Houston, Texas.
And greetings, I am Jasmine Morten, a second year business administration student from Kissimmee, Florida. And our team has recently launched Slice of Happiness Pizza Shop. It's a restaurant specializing in customizable pizzas, sizes, and beverages, where customers can choose from classic menu items or build their own pizzas with a wide variety of crusts, sauces, pizzas, and toppings. The shop offers dine-in, pickup, and delivery services, making it flexible choice for families, students, and professionals. As the business grows, we realize that tracking orders, customers, employees, and suppliers using spreadsheets and paper tickets is inefficient. Questions like which pizza toppings are most popular and who are our most top delivery customers are difficult to answer quickly. Implementing a database will allow us to centralize information, enforce consistency, and generate meaningful reports. With this system, we can record each order, link it to the customer and employee, track pizzas and toppings, and check supplier relationships. This will reduce errors, improve efficiency, and provide insights to guide further expansion. And then to our business rules, customers can place orders for pizzas, and each customer can place zero, one, or many orders over time, but each order is placed by one registered customer. And for walk-in customers who haven't joined or signed up, they're automatically a guest customer profile in the system. And another rule is that employees handle orders, meaning each order is processed by a single employee at the point of sale. Then orders contain pizzas. We sell many pizzas and they're customizable with sauces and crusts and toppings. And an order can include many pizzas. So there is a many to many relationship between orders and pizzas. And each order can contain several pizzas and each pizza can be sold in many orders. And then for our pizza have toppings, each pizzas can have multiple toppings and each topping can be used on many pizzas. This is also many to many. And suppliers provide toppings and ingredients. Each supplier can provide many toppings or ingredients, but each topping comes from one supplier. And then for our constraints, payments are restricted to cash, card, or online. And then our pizza sizes are restricted to small, medium, large, or extra large. And then for loyalty points, for our reward system, customers automatically default to 0. And then lastly, an order cannot exist without customer and employee information, and each order must be linked to a customer, which is the one who placed it, and an employee who processed it. And this prevents orders that have no owner or handler.
Now, for our data model, we focus on making sure that it follows the business rules while still being practical for how pizza shops actually work. First, we have the customer's entity. Each customer is identified by a customer ID, which is the primary key. So we store basic contact information and loyalty points. And the loyalty points automatically start at 0. We make sure to support the guest customers by using a single guest customer record. So walk-in orders can still be tracked without creating a new customer every single time. Next is employees. Each employee has a unique employee ID. One employee can handle multiple orders, but every order must be assigned to one employee. This keeps things organized and makes sure each order is clearly associated with who handled it. For orders is really the central part of the model. Each order includes an order ID, the customer ID, and the employee ID on the table, and a payment method. The payment method is limited to cash, card, or online using the E and UM. So we don't get inconsistent with the values as well. Both the customer and the employee fields are required, which enforces the rule that every order has to be linked to both. For the pizza entity, it stores information about the pizzas itself. Each pizza has a pizza ID along with the size, crust, sauce, and an optional pizza name. The pizza size is restricted to small, medium, large, or extra large, which helps keeps the data consistent across all orders. Suppliers are stored in their own entity with the supplier ID as the primary key. This allows the pizza shop to keep track of where the ingredients come from, which is important for organization and traceability. Toppings has a topping ID and it's linked to exactly one supplier. This way, every topping can be traced back to its supplier, while each supplier can still provide multiple toppings. As for order details, it's used to connect orders and pizzas, such an order. Since an order has many pizzas and the same pizza can appear in multiple orders, this resolves the many to many relationship. It uses composite primary key made up of the order ID and pizza ID, and it also stores the quantity of each pizza ordered. For pizza toppings works the same way, but it connects pizzas and toppings. It allows each pizza to have multiple toppings and each topping to be used on multiple pizzas using the composite primary key to prevent duplicates. Overall, this data model just keeps the data clean and follows the business rules and supports both regular and guest customers while allowing flexibility and customization. And this is it below.
Okay, so for the deliverable to relationship model customers, the database model for Slice of Happiness Pizza Shop is designed to organize all of the information and business needs to run smoothly, from customers and employees to pizza toppings, suppliers, and orders. Each major part of the business has its own table with clear primary keys and rules that keep the data clean and consistent. Customers and employees both have unique IDs and contact information, and orders link directly back to the customer who placed the order and the employee who handled it. Pizzas and toppings are also structured in a flexible way. Pizzas have sizes, crusts, sauces, and base prices, while toppings are tied to specific suppliers so that the shop can track ingredients, sources, and costs. The many to many relationship, like pizzas and their toppings, or orders and the pizzas inside of them, are handled through linking tables that make the structure both accurate and scalable. Overall, the model creates a complete picture of how information flows through the business when a customer places an order. The database can store exactly what pizzas they bought, which toppings were used, who prepared the order, and how much everything costs. Because the structure enforces valid payment methods, unique customer records, and require link between tables, it reduces errors that might happen with spreadsheets or paper tickets. This relationship model makes it easier for the pizza shop to answer questions like which toppings are most popular, which employees handle the most orders, or how much inventory is needed. It gives the business a solid foundation to grow while keeping operations organized and reliable.
So, moving into deliverable 3, which focuses on the database implementation for the Slice of Happiness Pizza Shop. As a team, we designed and implemented a relational database using SQL to organize all operational data for customers, employees, suppliers, menu items, orders, and sales analytics. So the first one, we have database structure overview. So to make the system efficient and scalable, we created multiple normalized tables, each handling a different part of the business. This structure ensures data integrity, reduces redundancy, and improves accuracy for reporting and decision making. So the core tables we created were the customers table, employees table, suppliers table, and toppings table. And the customers table was created with fields for names, contact information, and loyalty points. This allows Slice of Happiness to track repeat customers, reward loyalty, and manage targeted marketing. Our employees table stores staff details such as roles, contact numbers, and hire dates. This supports labor tracking and links employees to specific orders for accountability. The suppliers table stores information about ingredient vendors. This helps the shop monitor where each topping comes from and maintain supplier relationships. And the toppings table includes topping names, unit prices, and a foreign key linking each topping to its supplier. Using foreign keys enforces referential integrity, ensures toppings are always reference valid for suppliers. So Next, we have our menu structure and many-to-many design. This is shown in the pizzas table, and we designed this to store menu items with attributes like size, crust type, sauce type, and base price. We also use check constraints to ensure pizza sizes stay within approved options such as small, medium, large, or extra large. And our pizza toppings bridge table, because pizzas can have multiple toppings and toppings can belong to multiple pizzas, we created a many-to-many relationship using the pizza toppings bridge table, and this table makes it easy to customize pizzas and support build your own options. And next, we have our order processing tables. So we have our orders table, which tracks each transaction and stores customer IDs, employee IDs, payment methods, and total order amount. And this helps Slice of Happiness analyze customer behavior, employee performance, and payment trends. And next, we have our order details table, and this is to link pizzas to specific orders. And we created another many-to-many table called order details. And this records which pizzas were ordered, the quantity, and line level pricing. This table is essential for sales breakdowns and revenue calculations. Next, populating the database. So after creating the tables, we inserted sample data into suppliers, toppings, pizzas, customers, employees, orders, and order details. And this data set allows the system to operate realistically and enables all our analytical reports to function properly. And moving into SQL reports for business intelligence, we wrote several SQL reports to support data-driven decision-making for the pizza shop. Our daily sales summary calculates the total orders and revenue per day. This helps identify peak business days and plan staffing. Next, we have our monthly sales summary. This shows monthly order volume and revenue, helping spot seasonal trends or growth patterns. Next, we have our best-selling pizzas, and this ranks pizzas by units sold. This supports inventory management and menu optimization. Next, we have top pizzas by revenue. So this highlights pizzas that generate the most revenue, which helps evaluate pricing and promotional opportunities. Next, we have sales by pizza size, and this breaks down the number of pizzas sold by size. And it also helps determine which sizes we should be prioritizing when doing order inventory. Next, we have our top customers by total spend. And this identifies the highest spending customers, excluding guests, useful for loyalty programs and marketing campaigns. And then we have our customer order frequency, which shows which customers place the most orders. And this also helps measure loyalty and retention. And we have inactive customers. So this finds customers who haven't ordered in the last 30 days. And it also allows the shop to run re-engagement campaigns or send personalized offers.
So next we have payment method breakdowns, which reports how our customers prefer to pay, whether that's cash, card, or online payments. And this helps us understand what resources that we need for busy hours. Then for report 10, we have sales by employee. So it shows how much each employee contributes in terms of sales, and it tells us how many orders each employee handled and how much money these orders have brought in. Then we have top 3 employees by sales. So this focuses only on the top 3 employees who have generated the highest sales, and is helpful for employee recognition programs, bonuses, or selecting the employee of the month. Then we have busiest hours of the day. So it shows us the hour of the day when the shop gets the most orders and is critical for planning staffing levels, preparing dough, and getting delivery drivers ready. Then we have busiest day of the week. So it shows what day of the week brings in the most business, and this helps us plan inventory and staffing for the whole week. Then report 14, we have pizza with no sales. So it identifies the pizzas that didn't sell at all. And this is important because items with 0 sales might be taking up menu space or inventory unnecessarily. And for 15, we have average order value. So it calculates our average order value, basically how much the average customer spends per visit. And this number is important because it reflects our overall profitability. Then for 16, we have most profitable products. So it shows which pizza makes us the most profit over subtracting ingredient costs, and this helps us understand which items truly benefit the business financially.
Thank you.
Thank
Thank
you.
you.